I'm going to demonstrate the constructions of dilations of triangles. I'm going to begin with the concept that in a dilation we must have both a center of dilation, I call mine x, and we must have a scale factor. So I'm going to begin with the scale factor of 2. Let's say, for example, that we want to take a triangle we have. We'll call it triangle ABC. Quickly draw it out. And what we want to do is dilate this triangle through a scale factor of 2 from the given center of dilation. We'll call this point A, B, and C. In order to do this, we're going to take a line segment that goes from X to A and continue it well beyond A. So I'll use my straight edge. And think, if you will, of a flashlight. If this is a flashlight and you shine it onto an object, you could do something like shadow puppets, where an image will appear over here somewhere. And depending upon where you orient this picture relative to the flashlight, your picture will be larger or smaller. In this case, because we're looking for a scale factor of 2, what we're expecting is that all the dimensions of our dilated figure will be twice as large. Therefore, even the dimension from the center of dilation, in other words, this length XA, I need to take that length and double it. That would be my new coordinate, A prime. To do that, I'm going to take my compass, I'm going to put the needle on X and expand my bow until I'm exactly at point A. Then I pick up my compass, move it to where A was, and make a mark. This coordinate would now be called A prime because it's a copy of A. It's the image of A. I'll now do the exact same thing to points B and C. First, extend what would be my flashlight beam of light well beyond B. Then take my compass and from the point X, extend it to give me the length B, XB, and carry that out beyond B, giving me a new coordinate, B prime. Do the same thing with point C. Take my compass to measure from X to C, adjust it to be the right length, go from C out further by that same length, C prime. That now gives me 3 coordinates that are exactly twice as far away from the center of dilation, so that if I connect each of those coordinates together, I produce a triangle whose dimensions are each twice as long as the original triangle. Thus, if all 3 legs of a triangle are in a 2-to-1 ratio, in other words, they're proportional, the triangles will be similar with a scale factor of 2. In the event that I was to ask for a scale factor of 1/2, I would use the same concept. Let's take A, B, C and undergo a transformation of the type dilation with a scale factor of 1/2. So now what I need to do is find where the midpoint is of this. In other words, instead of going a full length of 1 unit, I want to go half a unit. Well, I can do that by using my compass. I'm going to produce perpendicular bisectors of each of these 3 legs. To do that, I'm going to be efficient in my process. I'm going to come from X, I'm going to choose a length that is more than halfway for all 3 of my segments, XA, XB, and XC. Then I'll keep that same length, and I'll go from A, crossing over. I produce what I call the football. If I take the endpoints of this football, and I were to draw a line segment all the way down from endpoint to endpoint, I would produce a line segment that is both perpendicular to, in this case not important, but also the bisector of this segment XA. So I'm going to call this point A double prime because it's another image of this. I don't want to confuse it with A prime. Now, because I kept the same length, I can do the same thing from point B. See this different football? I'm going to take my ruler, and now find the perpendicular bisector of XB. And now do the same thing with C. And you'll notice I'm producing a wider football. Here's my C football. So I'm going to connect this point with this point. And that gives me a point C double prime. Should have marked this one B double prime. And when I connect these three shapes, these three points that are images of my original, such that the scale factor is now 1/2 of what was original, I create a triangle that is similar, but all linear dimensions are exactly 1/2 as much. That is the process of constructing dilations.